All right. Hi, guys. So, we are starting chapter 7, which is the mole. And no, not the cute little animal here, and not the little mole that you see on someone's face. This is going to be the mole, the chemistry mole, okay? And this is very important for this unit and for the rest of this year. And I know I've said it's difficult, but that does not mean I don't think you can do it. I think you can totally master this unit and you're going to crush it. So let's just get started. Okay, so how many grains of salt are in this picture? Just from looking at it, can you guess? Because I don't know about you, but I can't. There are too many to count. How many water molecules are in one drop of water? And if you look, this one drop, this image here, it's just a portion of this one drop. And look how many molecules are in just that portion. Could you imagine how many are in the entire drop? I can't because it is too many to count. So that's why chemists need something to count a really large number. And so they created the mole. The mole is 602 septillion. So that's, here, let me do it this way. So it's 6.02 times 10 to the 23 atoms, or things. We're typically going to use atoms or molecules. But 6.02 times 10 to the 23rd, that's 6, 1, 2, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So then we just fill in this with all zeros. So that is comma 1, 1, 2, 3, comma 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 1, 2, 3, comma. So it's 602 septillion or sextillion molecules. It's a ton of molecules. And so if you think about it, in a mole we have one mole box, that's this, one mole box. All right, and inside that mole, we have all these atoms. All right. I know this isn't a great representation, but think about 602 sextillion atoms in a box. So that's a mole. So in one mole, so we can write this as either in one mole, there are 6.02 times 10 to the 23rd, or we can write it that there are Here, let's see if we can make room. You guys might have more room on your paper and won't need to erase it, but we can write this as saying that there is 1 mole per 6.02 times 10 to the 23rd atoms. Or we can say that there are 6.02 times 10 to the 23rd atoms per 1 mole. These conversions are greatly important, okay? All right, let's move on and do some practice. So let's practice a bit with these examples on this page. So we know that we have this mole box, and in the box there are 602 times 10 to the 23 things. So for instance, if I was to have 1 mole of bananas, that means I have 602 times 10 to the 23rd bananas in that box, in my 1 mole box. If I was to have 1 mole carbon atoms, I have 6.02 times 10 to the 23rd carbon atoms. If I have 1 mole of NaCl, that means I have 6.02 times 10 to 23rd NaCl molecules. I can have a mole of anything. I can have a mole of bananas, oranges, apples, a mole of carbon atoms, a mole of molecules. I could have a mole of Swedish fish, a mole of Skittles. As long as it is 600 or 6.02 times 10 to the 23rd, then it is a mole, okay? 6.02 times 10 to the 23rd. As long as it is that number, then we can call it a mole. Just like we can call a dozen or 12 a dozen, we can call 6.02 times 10 to the 23rd a mole. All right. So I want you to practice this. So we're going to do the first one together and the second one together. So let's say I have in 1 mole of HCl, so in 1 mole HCl, how many molecules of HCl are there? Well, in my mole, I know that I have 6.02 times 10 to the 23rd HCl. So I have, my answer is 6.02 times 10 to the 23rd HCl molecules. If I have 6.02 times 10 to the 23rd molecules of MgO, how many moles is that? So 6.02 times 10 to the 23rd. We know that it's 1 mole, so this is 1 mole. Okay. So before you leave this page, I want you to know that 6.02 times 10 to the 23rd is 1 mole. And 1 mole is 6.02 times 10 to the 23rd items. It could be bananas, it could be carbon atoms. As long as you have 6.02 times 10 to the 23rd of something, you have a mole of that thing. Okay? This is really important. I cannot stress how important understanding this is. So please, if you don't get this right now, please raise your hand. I'm very serious about that. Please raise your hand so I can come over and explain this to you in person and answer all of your questions. I know some of you feel weird about pausing and asking questions, but please, please do that, especially during this video. Okay, let's move on. Now that you understand that you have this mole box, and in that mole is 6.02 times 10 to the 23rd things. We are now going to convert between atoms, my 600.02 times 10 to the 23rd atoms, into moles, and from moles to atoms. Let's dive on in. So turning atoms into moles. When we go from atoms to moles, we are going to divide. So let's think about this. I've got my mole box, and in that mole box I have 6.02 times 10 to the 23rd. If I have a certain number of atoms and I want to know how many moles I have, I need to divide by my atoms. Just like if I was to have 24 eggs and I wanted to know how many dozens do I have? We know that there are 12 eggs in 1 dozen. So I would take my 24 and I'd divide by my 12 to get 2 dozen. Same thing here. I divide by the number of atoms I have. I start with the number of atoms I have, and then I'm going to divide by the number of atoms that are in a mole. Just like I had my 24 eggs, and I know that there are 12 eggs in 1 dozen. So that means I know that I have 2 dozen. Same thing, I have a certain number of atoms. I'm going to divide by how many atoms I have in my mole to figure out how many moles I have. I'm going to star this because if this page confuses you, you need to raise your hand and ask me for help, okay? We're going to go on to the next page and practice. Okay, so let's practice. First example, how many moles of iron are in a sample that has 7.91 times 10 to the 23rd atoms? So we always start with what we have. We know that we have 7.91 times 10 to the 23rd atoms. And now since I'm going from atoms to moles, I want to end with moles, right? I'm going from atoms to moles. I'm going to divide by the number of atoms in a mole. So 6.02 times 10 to the 23rd atoms are in 1 mole. And now I just divide my 7.91 times 10 to the 23rd divided by 6.02 times 10 to the 23rd, which equals 1.3 moles. And if you look at our equation, since the word atoms is on top here and it's on the bottom here, they cancel, leaving me with the mole. So I have 1.3 moles. So 7.91 times 10 to the 23rd atoms takes up 1.3 moles. So if I have my mole box, here are my mole boxes. We filled up my first mole box with atoms, and we filled up about 1/3 of the second mole box with atoms. So this is 1 mole. This is 0.31 moles. And together, that is 7.91 times 10 to the 23rd atoms. Okay, how many moles of CO2 are in a sample that has 5.82 times 10 to the 21 molecules? So we're always going to start with what I know. I know that I have 5.82 times 10 to 21 molecules of CO2. Now I'm going to divide by how many atoms or molecules or things that are in my mole. Again, remember, mole is just a grouping of things. This time I'm grouping molecules. The last time I was grouping atoms. This time I'm grouping molecules. So to get a mole, you need to have 6.02 times 10 to the 23rd of whatever you're measuring. In this case, we're measuring molecules. And we're measuring CO2 molecules. So 6.02 times 10 to the 23rd molecules is 1 mole. So now we divide my 5.82 times 10 to the 21 divided by 6.02 times 10 to the 23rd, which equals 0.0096 moles. So that means if I have my mole box, only a sliver of it has been filled with that many atoms. Okay? All right. And again, if we look at our units, molecules of CO2 cancels molecules of CO2, leaving me with the mole. Okay? Awesome. Let's move on. So we are going to turn moles into atoms now. And we do this by multiplying. So we multiply by 6.02 times 10 to the 23rd. So again, I have my mole box. And in my 1 mole box, I have 6.02 times 10 to the 23rd things. Okay? So let's say I have 2 dozen eggs, and I want to know how many eggs is that. I know that in 1 dozen I have 12 eggs, so I would take my 2 times the 12 to know that I've got 24 eggs. Well, we can make this look even better. I would take my 2 dozen, dozen times, and in 1 dozen I have 12 eggs, so 2 times 12 is 24. So let's look at the equation down here. My moles, like my 2 dozen, my 1 moles, my 1 dozen, and my 6.02 times 10 to the 23rd is my atoms, which is my 12 eggs. So I know that I've got 12 eggs in 1 dozen. I've got 6.02 times 10 to the 23rd atoms in 1 mole. All right, and then as you multiply across, that tells you how many eggs you had or how many atoms you have for that many number of dozen boxes. Okay? Let's practice this a bit. So for example, I have 4 moles of sulfur, or 4 moles of sulfur is how many sulfur atoms? So start with what you have. You have 4 moles. 4 moles of sulfur. I know that in 1 mole, I have 6.02 times 10 to the 23rd atoms. So now I take my 4 times my 6.02 times 10 to the 23rd, which tells me that I have I have to do this out. Okay. 6.02 times 10 to the 23rd times 4. I have 2.4 times 10 to the 24th atoms. So that means if I have 4 mole boxes, and each one I have 6.02 times 10 to the 23rd, 6.02 times 10 to the 23rd, 6.02 times 10 to the 23rd, and 6.02 times 10 to the 23rd. I could add each one all 4 times, or I could just take, right, I could do 6.02 times 10 to the 23rd plus 6.02 times 10 to the 23rd plus 6.02 times 10 to the 23rd plus 6.02 times 10 to the 23rd. Or we can just simply take 6.02 times 10 to the 23rd times 4. Okay? So that's what this first example shows you, that you just take your number of moles and multiply it by how many atoms are in a mole. And if you look at our units, the mole cancels the mole, leaving us measuring atoms. Boom, atoms. Okay, and the last one says 3.5 moles of carbon is how many carbon atoms? Well, we need to start with what we have. So we have 3.5 moles. And we're trying to go to atoms, so now we know that in 1 mole, we have 6.02 times 10 to the 23rd atoms. Now we just multiply across. 3.5 times 6.02 times 10 to the 23rd equals 3.5 times 6.02 times 10 to the 23rd equals 2.0107 times 10 to the 24th atoms of carbon. And if we look at our units, the mole cancels the mole, leaving me with atoms. That's why my answer is in atoms. Okay, that is all for today. You've got 8 practice problems to do. Call me up if you need help. Reference your notes, guys. Reference your notes. And let me know if you need any help. All right, let's get that practice done so you don't have to do it for homework. You got this.